Welcome. You have nothing to do right now, nowhere to be, and nothing to figure out. Let your body settle into wherever you are resting. Let your breathing slow, just a little. Tonight, we are going to drift together through one of the most beautiful stories ever told, the long, unhurried journey of humanity reaching upward toward the stars. Let it carry you gently into sleep. Long before telescopes or written language, ancient humans watched the sky with patient, careful eyes. They built great circles of standing stone, monuments like Stonehenge on the plains of England, aligned with such precision that the rising sun at midsummer would pour its light exactly through the chosen gap. These stones were a calendar, a clock, and perhaps a kind of temple all at once, a way of saying, we see the rhythm of the heavens, and we are part of it. In the ancient city of Babylon, scholars pressed small wedge-shaped marks into soft clay and recorded the wandering paths of the planets across the night sky. Around 700 years before the Common Era, these astronomers had already identified patterns in the movements of Venus, Mars, and Jupiter with remarkable care. Their tablets, baked hard and preserved for thousands of years, show us that the human desire to understand the heavens is older than almost anything else we have written down. Around 270 years before the Common Era, a Greek thinker named Aristarchus of Samos proposed something quietly extraordinary. He suggested that it was not the Earth sitting still at the center of everything, but the sun, and that our world moved around it. Most of his contemporaries did not accept this idea, but it was there, written and preserved, a seed of understanding waiting nearly 18 centuries to fully bloom. For nearly 1,400 years, the model of the cosmos drawn up by the Alexandrian astronomer Ptolemy held sway across much of the world. In his vision, Earth rested at the center of a series of crystalline spheres, each carrying a planet or a star in its slow, perfect circle. It was an orderly, even comforting picture of the universe, one that felt true for a very long time, because the mathematics behind it was careful enough to predict the sky with surprising accuracy. In the summer of 1054 of the Common Era, Chinese astronomers looked up and saw something extraordinary. A new star had appeared in the constellation we now call Taurus, blazing so brightly it could be seen in full daylight for nearly 3 weeks. They recorded it with great care. What they had witnessed was a supernova, the tremendous peaceful end of a massive star, and the glowing cloud it left behind is still visible today as the Crab Nebula, drifting slowly outward through the dark. In the year 1543, a Polish scholar named Nicolaus Copernicus published a careful, detailed argument that the sun, not the Earth, lay at the heart of our solar system. The book arrived in his hands as he lay on his deathbed, and it is said he held it just once before he passed. His idea did not sweep the world overnight. It moved slowly, the way great truths sometimes do, but it set in motion a revolution in human understanding that has never really stopped. In 1609, an Italian mathematician named Galileo Galilei turned a small, newly built telescope toward the night sky and saw things no human had ever seen before. Among his most wondrous discoveries were 4 small moons circling Jupiter, tiny points of light that moved night after night, clearly orbiting something other than the Earth. Here was living proof that not everything in the heavens revolved around our world. The universe, it turned out, was far more intricate and alive than anyone had imagined. Between 1609 and 1619, the German mathematician Johannes Kepler worked through an enormous amount of careful observation to arrive at 3 elegant laws describing how planets move. He showed that orbits are not perfect circles, but gentle ellipses, that planets move faster when closer to the sun and slower when farther away, and that the time a planet takes to complete one orbit is related in a precise mathematical way to its distance from the sun. In these 3 laws, the solar system revealed a quiet, underlying harmony. In 1687, Isaac Newton published a work that gathered the motions of the heavens and the falling of an apple into a single, unified idea. Every object in the universe pulls on every other object across any distance, with a force that depends on their masses and the space between them. With this one law, the wandering of planets, the arc of a thrown stone, and the pull of the moon on the tides all became part of the same story. The cosmos, for the first time, felt truly knowable. Let your body settle now, just a little more. Feel the weight of your limbs releasing into whatever is beneath you. There is nowhere to be, nothing to remember, nothing to hold. Each breath arrives on its own, slow and unhurried, and carries a little more of the day away with it. Let your thoughts drift like clouds moving across a wide, still sky. No need to follow any of them. You are safe, you are warm, and all that is asked of you now is simply to rest. On a cold March morning in 1926, a quiet, methodical American inventor named Robert Goddard stood in a snow-dusted field in Auburn, Massachusetts, and launched the world's first liquid-fueled rocket. It rose only about 12 meters into the air and flew for 2.5 seconds. To most eyes, it would have seemed a modest thing, a small metal cylinder sputtering upward over a frost-covered field. But in those 2.5 seconds, the age of modern rocketry was born. Around the same years, a Romanian-born German mathematician named Hermann Oberth was working independently toward the very same dream. He wrote, with deep conviction, that rockets could one day carry human beings beyond the atmosphere, and his books became something like sacred texts for a whole generation of young engineers. One of those engineers was a teenage boy named Wernher von Braun, who read Oberth's work and felt his life's direction settle into place. Ideas, it turns out, can travel farther than any rocket. In the autumn of 1944, a German rocket called the V-2 became the first human-made object to cross the boundary of space, rising more than 100 kilometers above the Earth. It was a weapon of war, built under terrible conditions, and its history carries a deep shadow. Yet in the physics of its flight, something new had happened. For the first time, an object built by human hands had touched the edge of the cosmos. The universe had been reached, however briefly, however darkly. When the war in Europe ended in 1945, American military teams moved quickly to find the German engineers who had built those rockets. Through a program that came to be known as Operation Paperclip, more than 100 German rocket scientists were brought to the United States. Among them was Wernher von Braun himself. They carried with them years of hard-won technical knowledge, and that knowledge would flow directly into the engines that would one day carry American astronauts to the moon. In 1949, the Soviet Union successfully detonated its first nuclear weapon, and the world shifted. The United States was no longer alone in possessing that terrible power. In the years that followed, both nations turned their gaze upward, understanding that whoever could place a rocket into orbit could also, in theory, deliver a warhead anywhere on Earth. The rivalry between two great powers quietly extended itself beyond the atmosphere into the vast and indifferent dark above. The phrase space race entered the language in the middle of the 1950s, giving a name to something that had been building for years. It described the urgent, unspoken competition between the United States and the Soviet Union to achieve the great milestones of spaceflight: first satellite, first human, first moon landing. Beneath the competition lay something more enduring, though, a shared human hunger to leave the surface of the Earth and see what lay beyond. The race was real, but the dream belonged to everyone. On the 4th of October 1957, the Soviet Union placed a small metal sphere into orbit around the Earth. It was called Sputnik 1, and it was about the size of a beach ball, polished aluminum, trailing 4 slender antennas. It circled the planet once every 96 minutes, traveling at roughly 28,000 kilometers per hour. The light entering your eyes on that October evening was the same light that glinted off humanity's first artificial moon, spinning silently overhead for all the world to see. As Sputnik 1 circled the Earth, it transmitted a simple, steady radio signal, a soft, repeating beep that any amateur radio operator could tune in and hear. Around the world, people pressed their ears to receivers and listened. In the United States, the sound carried a particular weight. It meant the Soviet Union had reached orbit first. Families gathered around their radios in living rooms across the country, listening to that quiet pulse from the sky, and the world felt suddenly, irrevocably different. Just 1 month after Sputnik 1, the Soviet Union launched Sputnik 2, and aboard it was a small dog named Laika, a stray from the streets of Moscow, chosen for her calm temperament. She became the first living creature to orbit the Earth, completing several circuits of the planet before the mission ended. Scientists of the era knew she would not return, and her journey was both a triumph of engineering and a moment that stirred something tender in people everywhere. She had looked down at the Earth from above, and in doing so, she had gone where no earthly creature had ever gone before. The United States launched its first satellite, Explorer 1, on the 31st of January 1958. It was a slender, cylindrical craft, far smaller than Sputnik, but carrying something Sputnik did not, a scientific instrument designed to measure radiation in the space around Earth. That instrument would go on to make a genuine discovery, detecting the belts of charged particles that wrap around our planet like invisible rings. Explorer 1 had arrived late to orbit, but it arrived with something to say. Let your body settle a little more deeply now. Feel the weight of your shoulders releasing, the muscles of your face growing loose and easy. There is nothing to hold on to tonight, no task waiting, no thought that needs answering. Let each breath come and go on its own, slow and unhurried. You are already drifting, already moving toward rest, as gently and naturally as a leaf carried along a slow, dark river. On the 1st of October, 1958, a new agency opened its doors in the United States. It was called the National Aeronautics and Space Administration, NASA, and it replaced an older body known as the National Advisory Committee for Aeronautics, which had guided American aviation research for decades. The transition was quiet, almost administrative on the surface, but it marked something profound. The United States had formally committed itself to the exploration of space. A new chapter had been opened, and the ink was still fresh. In 1959, 2 small rhesus monkeys named Abel and Miss Baker became the first animals to travel to space and return home alive. They rode a rocket to the edge of the atmosphere and back, enduring forces many times the weight of gravity, and both survived the journey in good health. Miss Baker, a tiny squirrel monkey, lived for another 26 years after her flight. Their safe return was a quiet reassurance, a sign that living creatures could endure the passage through space and come back whole. In January of 1959, the Soviet Union launched a spacecraft called Luna 1, and it did something no human-made object had ever done before. It slipped free of Earth's gravitational hold entirely. Luna 1 had been aimed at the moon, but missed by several thousand kilometers, sailing past and out into the wider solar system. Rather than a failure, it was a threshold crossed. For the first time, something built by human hands had broken away from Earth and become a traveler among the planets. Later that same year, in September of 1959, Luna 2 became the first human-made object to reach the surface of the moon. It did not land gently. It impacted the lunar surface at high speed, scattering metal across the ancient dust. But it had arrived. Something from Earth had traveled the 384,000 kilometers between 2 worlds and made contact. The moon, which humans had watched and wondered at for all of recorded history, had been touched for the very first time. Just 1 month later, in October of 1959, Luna 3 swung around the moon and turned its camera toward the side that no human eye had ever seen. The far side of the moon always faces away from Earth, locked in permanent rotation, and until that moment it had been entirely unknown. The images that came back were blurry and indistinct by modern standards, but they revealed a landscape of craters and highlands, ancient, undisturbed, and serene. A hidden face of our nearest neighbor had finally been glimpsed. On the 12th of April, 1961, a 27-year-old Soviet pilot named Yuri Gagarin climbed into a small spherical capsule called Vostok 1 and became the first human being to travel into space. He completed one full orbit of the Earth in 108 minutes, gazing out at a planet wrapped in a thin, luminous halo of atmosphere. He describes the view as beautiful. When he landed, ejecting from the capsule and parachuting down into a Russian field, the world had changed in a way it could never quite change back from. When Vostok 1 was being prepared, the engineers who built it made an unusual decision. They gave the capsule no manual flight controls for Yuri Gagarin to use. No one yet knew how a human mind might behave in the weightlessness and strangeness of space, and the designers worried that a pilot might become disoriented and make a dangerous error. A sealed envelope containing an override code was placed aboard, just in case. It was a small, careful act of caution at the edge of the unknown, and Gagarin, trusting and composed, flew the mission exactly as planned. Less than a month after Gagarin's flight, on the 5th of May, 1961, an American astronaut named Alan Shepard climbed into a capsule called Freedom 7 and rode a Redstone rocket into space. His flight lasted 15 minutes and 22 seconds, a brief, arsing journey that did not reach orbit, but carried him to an altitude of 187 kilometers above the Earth. When he splashed down in the Atlantic Ocean, he became the first American to have touched space. The two great spacefaring nations were now, in their own ways, among the stars. On a warm May evening in 1961, President Kennedy stood before a joint session of Congress and spoke words that would redirect the course of human history. He asked the nation to commit itself to landing a human being on the moon and returning them safely to Earth before the decade was out. It was a vast, unhurried ambition, offered not as a boast, but as a direction, a horizon toward which a whole civilization could quietly turn and begin to walk. On the 20th of February, 1962, John Glenn folded himself into a small capsule called Friendship 7 and became the first American to orbit the Earth. He circled the planet 3 times over nearly 5 hours, watching sunrises and sunsets blur together in a rhythm unlike anything a human had experienced before. From above, he described the Earth as luminous, its coastlines and cloud banks drifting past like a slowly turning dream. He landed safely in the Atlantic, and the nation exhaled. Let your body settle now, just a little more deeply into wherever you are resting. There is nothing to hold on to, nothing to solve. Each breath you take is slower than the last, and with every exhale, the day drifts a little further away. Your shoulders can soften, your hands can open. You are safe and still, and there is nowhere else you need to be. Simply rest here and let the quiet carry you. In June of 1963, a 26-year-old former textile worker named Valentina Tereshkova climbed aboard Vostok 6 and became the first woman to travel into space. She orbited the Earth 48 times over nearly 3 days, more time in space than all American astronauts combined, up to that point. She looked out at the Earth from her small window and later said it was the most beautiful thing she had ever seen. The stars, she said, were very bright. On the 18th of March, 1965, a Soviet cosmonaut named Alexei Leonov opened a hatch on his spacecraft and floated out into the open void of space, the first human being ever to do so. For 12 minutes, he drifted there, tethered by a slender cord, the Earth enormous and unhurried below him. the silence absolute. His suit swelled in the vacuum, making it difficult to move, and re-entering the airlock required tremendous effort. But he returned safely, carrying with him something no one had ever carried before. Just months later, in June of 1965, an American astronaut named Ed White stepped out of his Gemini 4 capsule and became the first American to walk in space. He maneuvered using a small handheld gas gun, turning slowly above a planet that filled his entire field of view. He later said that returning inside was the saddest moment of his life. The Earth below was brilliant with blues and whites, and he floated above it all in perfect weightless stillness, a human being suspended between worlds. Through the mid-1960s, the Gemini program quietly built the foundations that the moon landings would rest upon. Mission by mission, astronauts practiced the delicate art of rendezvous, two spacecraft finding each other in the immensity of orbit, and then docking, linking together in the dark. These were skills that had never existed before, techniques invented in real time, tested against the unforgiving silence of space. Each mission added another careful layer to a structure that would one day carry humans to another world. The light entering your eyes tonight left that moon long before any of these missions were ever imagined. In March of 1966, a Soviet spacecraft called Venera 3 became the first human-made object to reach the surface of another planet. It did not land gently. It struck the thick, shrouded atmosphere of Venus and was crushed before it could transmit any data from the surface. But it had traveled across the inner solar system and touched another world, crossing a distance that no machine had ever crossed before. Venus received it in silence, as it had received everything for billions of years. On the 27th of January 1967, 3 astronauts, Gus Grissom, Ed White, and Roger Chaffee, were seated inside their Apollo 1 capsule during a routine ground rehearsal when a fire broke out. In the pure oxygen atmosphere of the sealed cabin, the flames moved with terrible swiftness, and all 3 men were lost within seconds. It was a moment of profound sorrow for the space program and for the world. The mission that followed would carry their names forward, quietly and with great care, into everything that came after. In the same year, 1967, more than 100 nations signed a document known as the Outer Space Treaty. It declared that space belongs to no single country, that the moon and the planets and the stars beyond are the shared heritage of all of humanity. No nation may claim them, no weapon of mass destruction may be placed among them. It was a rare and tender agreement, born in a time of deep rivalry, and it still holds today, a quiet promise written across the sky for everyone who has ever looked up. In December of 1968, 3 astronauts, Frank Borman, Jim Lovell, and Bill Anders, became the first human beings to travel to the moon. Their spacecraft, Apollo 8, carried them across nearly 400,000 kilometers of open space, slipping into lunar orbit on Christmas Eve. They circled the moon 10 times, gazing down at its ancient cratered surface from just over 100 kilometers above. It was the farthest any human had ever traveled from Earth, and the world held its breath in quiet wonder. On that Christmas Eve orbit, astronaut Bill Anders turned his camera toward the horizon and photographed something that no one had ever seen quite this way before: the Earth rising above the moon's gray surface. Small and luminous, wrapped in blue and white, it floated against the absolute darkness of space. The image, known ever since as Earthrise, moved something deep in the human heart. For the first time, people could see their world as it truly was, one whole, fragile, radiant thing, drifting in an ocean of silence. On the 20th of July, 1969, Neil Armstrong and Buzz Aldrin guided their lunar module, Eagle, down through the silence and settled gently onto the surface of the moon. Armstrong stepped out first, his boot pressing into the fine gray dust, and spoke words that traveled instantly back across the void to every listening ear on Earth. They were there for only a matter of hours, but in those hours, something shifted permanently in what it meant to be human. The light that fell on them that day had traveled from the sun across the same ancient distance it always had, only now it fell on people standing on another world. Let your body settle a little more deeply now into the warmth around you. There is nowhere you need to be, nothing you need to hold on to. Let your shoulders soften. Let your hands rest open and still. Breathe in slowly and breathe out even more slowly. With each breath, the thoughts of the day grow lighter, drifting away like mist. You are safe, you are still, and sleep is already drawing near. While Armstrong and Aldrin walked upon the moon, their crewmate Michael Collins remained alone in the command module, Columbia, orbiting silently above. Every 2 hours, he circled the moon, sometimes passing over the far side where no radio signal could reach, the most solitary any human being had ever been. He has described those moments not with loneliness, but with a deep and settled calm. He was the keeper of the ship, waiting in the stillness, watching the stars wheel slowly past. Across the Earth, approximately 600 million people gathered around television sets to watch the Apollo 11 landing unfold. In living rooms and village squares, in hospitals and schools, people sat together in the blue flicker of the screen, watching images transmitted across the void from another world. It remains one of the most widely shared moments in human history. A single evening when nearly 1 in 5 people alive on Earth turned their attention to the same extraordinary thing happening far above them. Before leaving the lunar surface, the Apollo astronauts placed small arrays of corner cube mirrors on the moon, instruments called retroflectors. Scientists on Earth still aim laser beams at them today, measuring the time it takes for the light to return, and in doing so they can calculate the distance to the moon with extraordinary precision. The moon, they have found, is slowly drifting away from Earth by about 3.8 centimeters each year. Those small mirrors, resting silently in the dust, continue their quiet work more than half a century later. In April of 1970, the crew of Apollo 13, Jim Lovell, Jack Swigert, and Fred Hayes, were 2 days into their journey to the moon when an oxygen tank in the service module ruptured without warning. The mission to land on the moon was abandoned immediately, using the lunar module as a lifeboat. The 3 men looped around the moon and began the long, cold journey home, navigating with extraordinary care and patience. They splashed down safely 4 days later, their return a testament to the steadiness that can carry people through even the most difficult passage. Across 6 Apollo missions, 12 human beings walked upon the surface of the moon between 1969 and 1972. They came from different backgrounds and carried different temperaments, but each one descended that ladder and placed their feet on ground that had known only silence and starlight for 4.5 billion years. They drove rovers across the highlands, collected rocks, and gazed back at the Earth hanging in the black. 12 people, a number small enough to fit around a single table, who carried all of humanity with them. In September of 1970, a Soviet spacecraft called Luna 16 descended to the moon's surface, drilled a small core of lunar soil, sealed it inside a return capsule, and launched back toward Earth, entirely without a human crew. It landed safely in Kazakhstan, carrying just over 100 grams of lunar material gathered by a machine working alone in the silence. It was the first time a robotic mission had ever collected a sample from another world and brought it home. Those small grains of ancient dust had rested undisturbed since long before the first living thing ever drew breath on Earth. In April of 1971, the Soviet Union launched Salyut-1, the world's very first space station. It rose into orbit as a slender, cylindrical structure, modest by later standards, but remarkable in what it represented, a permanent human foothold above the Earth. A crew of 3 cosmonauts docked with it and lived aboard for 23 days, conducting experiments and gazing down at the turning world below. The station orbited quietly for 6 months before re-entering the atmosphere, having opened a new chapter in the long story of human presence in space. In December of 1971, a Soviet spacecraft called Mars 3 became the first human-made object to land softly on the surface of Mars. After a journey of many months through the cold dark between worlds, it descended through the thin Martian atmosphere and touched down on the rust-colored plains. It transmitted a signal for about 20 seconds before falling silent, the reasons still not entirely understood. But for those 20 seconds, humanity had placed something gently upon another planet, and the red world had, for a moment, received it. Launched in March of 1972, Pioneer 10 was the first spacecraft ever built with the intention of leaving our solar system entirely. It flew past Jupiter, using the giant planet's gravity to slingshot itself outward, and then continued onward into the deep unknown beyond the planets. Somewhere out there, it still drifts billions of kilometers from the Sun, in a region of space so remote that even the Sun would appear as nothing more than a very bright star. It carries a small gold anodized plaque bearing images of a man, a woman, and the location of our world. In 1973, the United States launched Skylab, its first space station, fashioned in part from a converted Saturn rocket stage. 3 separate crews visited it over the following year, living and working in its roomy interior, conducting medical experiments and studying the Sun through telescopes mounted on its hull. Astronauts found that the human body adapted to weightlessness in surprising and fascinating ways, their spines gently lengthening, their faces softly rounding. Skylab drifted above the Earth like a warm and humming outpost, a rehearsal for the long-duration missions that would come decades later. Let your thoughts settle now, like dust drifting slowly down through still air. There is nowhere you need to be, and nothing you need to hold on to. Feel the weight of your body resting fully, every muscle releasing a little more with each slow breath. The day has passed, and all that remains is this quiet moment. Let your breathing find its own unhurried rhythm, and allow each exhale to carry you a little further into stillness. You are safe, you are warm, and rest is already finding you. In 1974, a spacecraft called Mariner 10 became the first ever to visit the planet Mercury, the smallest and innermost world of our solar system. It swept past Venus first, using that planet's gravity to bend its path inward toward the Sun, then flew close to Mercury 3 separate times. The images it returned showed a cratered, silent world of extremes, scorching in sunlight, bitterly cold in shadow, its ancient surface pocked and scarred by billions of years of impacts. It was a world that had waited in stillness since the very beginning of the solar system. In July of 1975, American and Soviet spacecraft docked together in orbit for the very first time. The Apollo and Soyuz missions had been designed independently by 2 nations that had spent years in fierce rivalry, yet their crews shook hands through the connecting tunnel and shared meals in each other's cabins. It was the first international human spaceflight, a handshake above the clouds that carried a meaning far larger than the mission itself. For a brief time, the boundary between 2 worlds dissolved, and 2 sets of human hands reached across it. In the summer of 1976, 2 American spacecraft, Viking 1 and Viking 2, settled onto the surface of Mars and began searching for something extraordinary. Their instruments scooped up Martian soil and ran a series of careful experiments designed to detect signs of biological life. The results were intriguing but inconclusive, and scientists still discuss them with quiet, patient curiosity to this day. Whatever the answer, the Vikings had become the first fully functional laboratories ever to operate on another planet, working methodically in the amber stillness of the Martian afternoon. In the late summer of 1977, two twin spacecraft, Voyager 1 and Voyager 2, lifted off from Earth within weeks of each other, bound for the outer reaches of the solar system. They swept past Jupiter and Saturn, then diverged, one curving toward Uranus and Neptune, the other arcing upward out of the plane of the planets entirely. Together, they revealed worlds of breathtaking intricacy, rings of ice, moons with volcanoes, storms the size of continents. The light entering your eyes tonight has traveled a far shorter distance than either of these quiet travelers has journeyed since their launch. On April the 12th of 1981, exactly 20 years after Yuri Gagarin first rode a rocket into the sky, the Space Shuttle Columbia lifted off from Cape Canaveral. It was unlike anything that had flown before, a winged spacecraft that launched like a rocket and landed like a glider, returning its crew to Earth on a runway. Astronauts John Young and Robert Crippen rode it into orbit and back again. And when Columbia touched down on the dry lake bed at Edwards Air Force Base, a new era had begun, one in which space travel would slowly, steadily become something that could be done again and again. In June of 1983, Sally Ride became the first American woman to travel into space. She flew aboard the Space Shuttle Challenger as a mission specialist, conducting experiments and operating the shuttle's robotic arm with steady, practiced skill. She had been selected from thousands of applicants, and she carried that responsibility with quiet composure. Her journey opened a door that had long been waiting, and through it, countless others would one day follow. On the morning of January the 28th, 1986, the Space Shuttle Challenger broke apart 73 seconds after launch, taking the lives of all 7 crew members aboard. Among them was Krista McAuliffe, a schoolteacher who had been chosen to be the first civilian in space. The nation paused in shared grief, and the shuttle program was grounded for nearly 3 years, while engineers worked to understand what had gone wrong and how to make things right. Their names are remembered with deep and lasting tenderness. In February of 1986, the Soviet Union launched the Mir space station, a name that means both peace and world in Russian. Module by module, it grew into a remarkable outpost, and for nearly a decade it was home to a continuous succession of human inhabitants. Cosmonauts lived and worked there through the changing seasons far below, tending experiments, repairing equipment, and gazing down at a planet that slowly turned beneath them. Mir became a place where human endurance was tested quietly, day after patient day. In April of 1990, the Space Shuttle Discovery carried a remarkable cargo into orbit, the Hubble Space Telescope. Deployed above the blurring effect of Earth's atmosphere, Hubble was designed to see the universe with a clarity never before achieved from the ground. It was the size of a large school bus, wrapped in silver insulation, and it drifted into its orbit, like a patient observer taking its place at a window that had no glass, no weather, and no end. A new era of seeing was about to begin. When Hubble's first images arrived, scientists discovered that its primary mirror had been ground to the wrong shape, a flaw smaller than a fraction of a human hair, yet enough to blur every image it sent home. In December of 1993, a crew of astronauts aboard the Space Shuttle Endeavour performed a series of delicate spacewalks, carefully installing corrective optics by hand. It was like fitting a contact lens onto a telescope in the void of space. When the repaired images arrived, they were breathtaking, and the universe came into sharp, luminous focus. Let your body settle a little deeper now. Feel the weight of your limbs release, one by one, into the surface beneath you. There is nothing to hold on to tonight, no task, no thought that needs answering. Simply breathe, slowly and evenly, and let each exhale carry away a little more of the day. You are here, you are still, and the night is long and unhurried. Rest is already finding you. In 1995, Astronomers pointed the Hubble Space Telescope at a tiny, seemingly empty patch of sky, an area no larger than a grain of sand held at arm's length, and exposed the image for 10 full days. What emerged was astonishing: nearly 3,000 galaxies, each one a vast island of billions of stars, all contained within that single unremarkable corner of the sky. The light from the most distant of those galaxies had been traveling for over 12 billion years before it reached Hubble's mirror, setting out long before our own solar system existed. Also in 1995, the Galileo spacecraft arrived at Jupiter after a 6-year journey across the inner solar system. It slipped into orbit around the great planet and began a methodical, unhurried study that would last 8 years. Galileo revealed Jupiter's atmosphere in extraordinary detail, discovered evidence of a liquid ocean beneath the icy surface of the moon Europa, and watched volcanic eruptions on the moon, Io, with patient, steady observation. It circled Jupiter 35 times before its mission was gently concluded in 2003. In 1996, American astronaut Shannon Lucid traveled to the Mir space station and stayed for 188 days, the longest space flight by an American at that time, and the longest ever by a woman anywhere in the world. She conducted scientific experiments, exercised to preserve her health in weightlessness, and read stacks of books she had brought along for the long, quiet stretches between tasks. When she finally returned to Earth, she had circled the planet nearly 3,000 times, carried gently along by an orbit that never grew tired. On July the 4th of 1997, the Mars Pathfinder spacecraft bounced to a landing on the Martian surface inside a cocoon of airbags, then opened its petals to reveal a small 6-wheeled rover named Sojourner. No larger than a microwave oven, Sojourner rolled cautiously across the rust-colored ground, examining rocks and transmitting data back across the vast distance to Earth. It was the first rover ever to move across the surface of another world. A tiny, deliberate traveler making tracks in soil that no wheel had ever touched before. In 1995, 2 Swiss astronomers named Michael Mayer and Didier Queloz confirmed something that had long been wondered about but never proven: a planet orbiting a distant star very much like our own Sun. The world they found, given the name 51 Pegasi b, circled its star so closely that its year lasted only 4 days. It was nothing like any planet in our solar system, a vast, hot, gaseous world hugging its sun in a tight, warm embrace. But its existence quietly changed everything, whispering to us that planets are not rare, and that other suns, too, have worlds of their own turning slowly around them. In 1998, the first piece of the International Space Station was carried into orbit, a Russian-built module called Zarya, meaning dawn. It was a compact, cylindrical structure, solar panels spread wide like outstretched arms, drifting alone in the darkness above Earth. Over the years that followed, piece by piece, module by module, it would be joined by contributions from 15 nations, assembled by human hands in the weightless silence of low Earth orbit. What began as a single module floating in the dark would grow, slowly and patiently, into the largest structure humanity has ever placed among the stars. On the 1st of February 2003, the Space Shuttle Columbia was returning home after a 16-day mission. During its launch 2 weeks earlier, a piece of foam insulation had broken away and struck the leading edge of the shuttle's wing. As Columbia descended through the atmosphere, superheated air found that damaged place and worked its way inside. The 7 crew members, Rick Husband, William McCool, Michael Anderson, Elon Ramon, Kalpana Chawla, David Brown, and Laurel Clark, were lost before they could reach the ground. The world paused in sorrow, honoring 7 lives devoted to the quiet, courageous work of exploration. Since the 2nd of November, 2000, there has not been a single day when human beings were not living in space. On that date, the first resident crew arrived aboard the International Space Station and settled in, beginning an unbroken chain of human presence in orbit that continues even now. Crews have rotated in and out. Languages have shifted between Russian and English and others. Faces have changed, but the station has never been empty. Somewhere above the turning Earth, at every quiet moment of every day and night, people have been floating gently among the stars, going about their work. The International Space Station travels around Earth at an altitude of roughly 400 kilometers, moving at about 28,000 kilometers per hour. At that speed, it completes a full orbit of the planet in just 90 minutes, meaning the crew aboard it witnesses 16 sunrises and 16 sunsets every single day. From their windows, the continents drift by, like slowly turning pages, oceans, mountain ranges, the golden threads of city lights at night. The station is not far away by any cosmic measure. It is close enough that, on a clear evening, you can sometimes watch it cross the sky above you, a steady, unhurried point of light. In 2004, a small, privately built spacecraft called Spaceship Pony rose above the Mojave Desert and crossed the boundary of space under its own power. It was the first time a vehicle designed and funded entirely outside of any government had reached space. The pilot, Mike Melville, looked out at the thin blue line of the atmosphere curving away below him and floated a handful of candy-coated chocolates in the weightless cabin, watching them drift. It was a small, human moment at the edge of the sky, a reminder that the desire to reach beyond the atmosphere belongs not only to nations, but to people. Let your body rest now, just as it is. There is nothing left to carry tonight. No task waiting, no thought that needs your attention. Let your shoulders release. Let your hands grow heavy and still. Breathe in slowly and breathe out even more slowly, feeling the quiet settle around you like a warm blanket. The day is finished. You have done enough. Let your mind drift now, easy and unhurried, like a leaf turning gently on still water, moving nowhere in particular, needing to arrive nowhere at all. In January of 2004, two rovers named Spirit and Opportunity touched down on opposite sides of Mars, each cushioned by airbags as they bounced across the ancient red surface. They were designed to operate for 90 days. Spirit explored for 6 years before falling silent. Opportunity kept rolling for 15 years, traveling over 45 kilometers across a world no human had ever touched. It studied ancient riverbeds and crater walls, finding evidence that liquid water had once moved across that landscape long, long ago. When Opportunity finally went quiet in 2018, it had become one of the most enduring travelers in the history of exploration. Also in 2004, the Cassini spacecraft arrived at Saturn after a 7-year journey and slipped gracefully into orbit around the ringed giant. Over the 13 years that followed, it circled Saturn 294 times, mapping its rings with extraordinary care and studying its family of moons in patient, unhurried detail. The rings, it revealed, were made of countless pieces of ice, ranging from tiny grains to chunks the size of houses, all orbiting in a delicate, ancient dance. The light reflected from those rings, traveling across more than 1 billion kilometers, reached Cassini's cameras and became some of the most beautiful images ever gathered by a spacecraft. On the 14th of January 2005, a small probe named Huygens separated from Cassini and descended through the thick orange haze of Titan, Saturn's largest moon. It parachuted slowly downward for more than 2 hours, measuring the air around it, listening, sampling, and finally touched down on a world nearly 1.4 billion kilometers from Earth, the most distant landing any human-made object had ever made. Huygens found a landscape of rounded pebbles and a hazy amber sky, a place strangely familiar and utterly alien at once. It sat quietly on Titan's surface and transmitted its findings for over an hour before the signal faded into silence. In January of 2006, a spacecraft named New Horizons lifted off from Earth and began one of the longest, most patient journeys ever attempted. It was headed for Pluto, a small, icy world at the outermost edge of the known solar system, nearly 5 billion kilometers away. The journey would take 9.5 years, and for much of that time, the spacecraft would travel in a kind of electronic slumber, its systems quietly hibernating to conserve power. New Horizons carried within it a small portion of the ashes of Clyde Tombaugh, the astronomer who had first discovered Pluto back in 1930, a gentle, tender tribute carried all the way to the edge of the solar system. In the summer of 2008, a lander named Phoenix settled onto the northern plains of Mars and carefully extended a robotic arm into the rusty soil. Just a few centimeters below the surface, it found something remarkable: water ice, frozen and still, preserved in the cold Martian ground. Scientists had long suspected it might be there, but Phoenix confirmed it with quiet certainty. The ice sat just beneath a thin layer of dust, patient and undisturbed, perhaps for millions of years. That discovery shifted the way we think about Mars, not as a barren, dry relic, but as a world that still holds water, locked away in the cold dark beneath its ancient surface. In March of 2009, NASA launched a space telescope named Kepler, designed to do one thing with extraordinary dedication: stare at a single patch of sky and watch for the faint dimming of starlight that signals a planet passing in front of its star. Over the years that followed, Kepler monitored more than 150,000 stars simultaneously, watching, measuring, and listening with extraordinary patience. It confirmed the existence of over 2,600 planets orbiting other suns, worlds of every imaginable kind: rocky ones, gaseous ones, scorching ones, and a handful nestled in the gentle warmth of their star's habitable zone. Kepler showed us that planets are not rare at all. They are everywhere, scattered across the galaxy, like grains of sand on an endless shore. On the 14th of July, 2015, New Horizons finally arrived at Pluto after 9.5 years of silent travel. In the hours it swept past, it gathered more information about that distant world than all previous decades of observation combined. It revealed mountains of water, ice rising 3,000 meters high, broad, smooth plains of frozen nitrogen, and a vast, pale region shaped unmistakably like a heart, a nitrogen glacier so large it could hold the entire state of Texas within its curves. The images arrived slowly, taking hours to travel back across the solar system, but when they did, they showed a world of extraordinary, unexpected beauty, a reminder that even the most distant and forgotten places hold quiet wonders of their own. On the 21st of December, 2015, a Falcon 9 rocket lifted off from Cape Canaveral, carrying a payload of satellites into orbit. That alone was familiar enough. But what happened next had never been done before. The rocket's first stage booster separated, turned around, and flew itself back to the launch site, firing its engines to slow its descent, extending 4 landing legs and settling gently and precisely onto a concrete pad. It stood there upright, still and whole, ready in principle to fly again. It was a quiet revolution in how we think about spaceflight. The idea that a rocket need not be discarded after a single use, that the sky could be traveled more gently, more economically, more often. In September of 2015, an instrument called the Laser Interferometer Gravitational Wave Observatory detected something that physicists had been searching for across 50 years, a ripple in the fabric of space-time itself. 2 black holes, each many times the mass of our Sun, had spiraled toward each other over billions of years, and finally merged in a fraction of a second, releasing more energy than all the stars in the observable universe combined for that brief instant. That collision sent a wave through the fabric of space and time, and it reached Earth as a distortion smaller than 1/10,000th the width of a proton. The instrument felt it anyway. It was perhaps the most delicate measurement ever made in the history of human science. In December of 2015, British astronaut Tim Peake launched aboard a Soyuz capsule and docked with the International Space Station, becoming the first British astronaut to visit the station under the European Space Agency. He spent nearly 6 months aboard, conducting scientific experiments, performing a spacewalk, and even running the London Marathon on a treadmill while orbiting 400 kilometers above the Earth. He brought with him a quiet sense of wonder that he shared generously, photographing the British Isles from above, speaking with school children across the country, and showing that space, in its way, belongs to everyone. The light from his orbit passed over every nation below without pause or preference. Let yourself rest now, just as you are. There is no need to hold on to anything, not the day just passed, not the thoughts still drifting through your mind. Let them go, one by one, the way leaves release from a branch in autumn, unhurried and without effort. Feel the weight of your body settle, heavy and warm, into the stillness beneath you. Your breath is slow and even. Each exhale carries a little more tension away. You are safe, you are still, and there is nowhere you need to be. Let your thoughts grow softer now, less distinct, like distant lights seen through a window on a quiet evening, beautiful and far away. In July of 2016, a spacecraft named Juno arrived at Jupiter after a 5-year journey and slipped into a tight polar orbit around the largest planet in our solar system. It was built to survive the intense radiation belts that surround Jupiter, protected by a titanium vault around its most sensitive instruments. As it swooped close to the cloud tops, it mapped Jupiter's magnetic field in extraordinary detail, finding it far more complex and irregular than anyone had expected. Not a simple dipole like Earth's, but a tangled, layered structure generated deep within the planet's interior. Juno also revealed that Jupiter's famous bands of cloud extend hundreds of kilometers downward, far deeper than the surface we can see. On the 6th of February 2018, SpaceX launched the Falcon Heavy rocket for the first time. At that moment, the most powerful operational rocket in the world, capable of lifting more than 63,000 kilograms into low Earth orbit. As a test payload, the company placed one of its founders' personal cars, a red convertible, into an orbit that would carry it out toward Mars. A mannequin in a spacesuit sat in the driver's seat, one hand resting on the wheel, a small plaque on the dashboard reading the words "Do not panic." The two side boosters returned to Earth and landed simultaneously, side by side, in a moment so precisely choreographed it seemed almost impossible. It was a moment of levity and audacity woven together, a glimpse of how spaceflight was changing. The Parker Solar Probe launched in the summer of 2018 and became the fastest human-made object ever built. Designed to study the Sun from closer than any spacecraft before it, it swoops through the outer layers of the solar corona, enduring temperatures of nearly 1 million degrees Celsius. A heat shield made of carbon composite foam stands between the delicate instruments and the blazing light, keeping them cool even as the probe skims just a few million kilometers from the solar surface. At its fastest, it travels at nearly 700,000 kilometers per hour, a speed so extraordinary that it covers the distance between cities in fractions of a heartbeat. It moves through fire with extraordinary stillness. In April of 2019, a global network of radio telescopes working in perfect coordination produced the first true image of a black hole. The Event Horizon Telescope linked observatories across several continents, turning the entire Earth into a single enormous instrument. The image revealed the black hole at the center of a distant galaxy called Messier 87, a glowing ring of superheated gas surrounding a region of absolute darkness, where gravity is so powerful that not even light can escape. It was a thing humanity had long imagined but never seen. That soft, luminous ring, blurred at its edges like a candle seen through fog, confirmed something once thought beyond the reach of any eye. In October of 2020, NASA's OSIRIS-REx spacecraft reached down and briefly touched the surface of asteroid Bennu, collecting a small sample of ancient rock and dust. The contact lasted only a few seconds. A gentle puff of nitrogen gas loosened the surface material, and the spacecraft collected it before pulling away. Bennu is a carbon-rich asteroid, a remnant from the earliest days of the solar system, unchanged for billions of years. The sample it carried back to Earth arrived in September of 2023, offering scientists a direct window into the raw ingredients that once drifted through space before our world existed. Holding that dust is, in a quiet way, holding the beginning. On the 30th of May, 2020, SpaceX's Crew Dragon capsule lifted 2 NASA astronauts into orbit, the first time a commercially built and operated spacecraft had carried humans to the International Space Station. Bob Behnken and Doug Hurley rode atop a Falcon 9 rocket from the same launch pad that had sent Apollo astronauts to the Moon more than 50 years before. The capsule was sleek and modern, its interior lit in soft white, its touchscreen controls a world away from the switches and dials of earlier eras. It was a turning point, the moment when human spaceflight, once solely the domain of governments, became something that private enterprise could carry forward. A new kind of door had opened. Perseverance rover touched down on the floor of Jezero crater on Mars on the 18th of February, 2021, landing in a place scientists believe was once an ancient lakebed. Its mission was unlike those of rovers before it, not simply to study the geology of Mars, but to search for traces of ancient microbial life that may have existed billions of years ago when Mars was warmer and wetter. Perseverance drilled carefully into the rock, collecting core samples sealed in small tubes, waiting for a future mission to carry them home. It also produced oxygen from the thin Martian atmosphere using an instrument no larger than a lunchbox. Each small act was a rehearsal for the day humans might breathe there. On the 19th of April, 2021, a small helicopter named Ingenuity lifted off from the Martian surface and hovered for about 30 seconds, the first powered, controlled flight ever made on another planet. Its rotors had to spin at nearly 2,500 revolutions per minute to generate lift in an atmosphere less than 1% as dense as Earth's. It weighed less than 2 kilograms and carried a small piece of fabric from the Wright brothers' original flyer, a quiet thread connecting the first flight on Earth to the first flight beyond it. Ingenuity was only meant to fly 5 times. It flew over 70 before its mission ended. It proved in the most unhurried and methodical way that the sky of another world could be navigated. On Christmas Day of 2021, the James Webb Space Telescope lifted off from a launch site in French Guiana and began a month-long journey to its orbital position 1.5 million kilometers from Earth. Webb was designed to see the universe in infrared light, wavelengths invisible to the human eye, but rich with information about the oldest and most distant objects in existence. Its primary mirror, made of 18 hexagonal gold-coated segments, spans over 6.5 meters across. A 5-layer sunshield, the size of a tennis court, keeps it cold enough to detect the faintest warmth from ancient starlight. It was the result of decades of work by thousands of people, and it arrived at its destination with extraordinary precision. In July of 2022, the James Webb Space Telescope released its first full-color images, and the world paused to look. Among them were galaxies that had formed just 300 million years after the Big Bang, the oldest light ever directly observed, stretched by the expansion of the universe from ultraviolet into the warm hues of infrared. These were not distant specks, but fully formed structures, ancient beyond imagining, glowing softly in Webb's images like embers from the very first fires of creation. The light now entering our instruments had been traveling for over 13 billion years to reach us. In a single image, humanity looked back almost to the beginning of time itself and found it filled with light. Let your eyes stay closed now, and let your breath find its own slow rhythm. There is nothing left to hold on to tonight. Feel the weight of your thoughts growing lighter, the way mist lifts from a still lake in the early morning, dissolving without effort into the open air. Your body is heavy and warm, fully supported, fully at rest. The day has ended. The world outside is hushed. Let each breath carry you a little further from wakefulness, a little deeper into the soft, wordless quiet that waits just beneath the surface of thought. You are drifting now, gently and without direction, like a leaf on still water. There is nowhere to go. There is only this, the warmth, the stillness, the slow and easy dark. In April of 2021, China launched the Tianhe core module into orbit, marking the beginning of construction on the Chinese space station. Tianhe, whose name means harmony of the heavens, serves as the living and working heart of the station, housing crew quarters, life support systems, and a docking hub for additional modules. Over the following years, 2 further modules were attached, completing a T-shaped structure that now carries Chinese taikonauts on missions lasting up to 6 months. It represents China's emergence as a fully independent spacefaring nation, capable of designing, building, and operating its own home among the stars. The station orbits quietly above the Earth, another lantern in the long human tradition of reaching upward. In September of 2022, a spacecraft, the size of a vending machine, struck a small asteroid named Dimorphos and changed its orbit. The mission was called the Double Asteroid Redirection Test, and it was humanity's first deliberate attempt to alter the path of a natural object in space. Scientists measured the result carefully and found that the impact had shortened Dimorphos's orbital period by 33 minutes, far more than expected. It was a quiet but profound demonstration that with enough foresight and preparation, our species can reach out and gently nudge the cosmos to protect itself. The universe had always shaped us. Now, in the smallest of ways, we had shaped it back. Late in 2022, NASA's Artemis I mission sent an uncrewed Orion capsule on a sweeping journey around the Moon and back. The capsule traveled farther from Earth than any spacecraft designed to carry humans had ever gone, nearly 450,000 kilometers at its most distant point. It looped behind the Moon, skimmed low over its ancient surface, and returned safely to Earth after 25 days, splashing down in the Pacific Ocean. No one was aboard, yet the mission carried the quiet weight of everything that came before it and the soft promise of everything still to come. Right now, as you rest, a small golden spacecraft is drifting through the dark beyond our solar system, farther from Earth than anything humanity has ever sent. Voyager 1 is over 23 billion kilometers away, so distant that a radio signal traveling at the speed of light takes more than 21 hours to reach it. It crossed into interstellar space in 2012, leaving behind the bubble of particles that surrounds our Sun and entering the vast, undisturbed medium between the stars. It moves through a silence so complete and a darkness so absolute that no human sense could perceive it, and yet it carries our fingerprints, still traveling, still transmitting, still ours. Tucked inside each of the 2 Voyager probes is a golden record, a 12-inch copper disc plated in gold, carrying sounds and images chosen to represent life on Earth. Greetings in 55 languages are encoded there, alongside music from many cultures, the sound of rain and thunder, the calls of birds, the laughter of children, and the low rumble of the sea. Photographs of forests, deserts, and human faces were encoded into its grooves. A stylus was included so that whoever might find it could learn how to listen. It was a letter written not to any known recipient, but to the open possibility of the universe itself, sent with care and with hope. As of 2024, Astronomers have confirmed the existence of more than 5,500 worlds beyond our own solar system, planets orbiting other stars, each one a place where the laws of nature hold sway just as they do here. They come in extraordinary variety: scorched giants skimming close to their suns, frozen wanderers in deep orbits, rocky worlds that might hold liquid water on their surfaces. And these confirmed planets are only the ones we have found so far. Scientists estimate that the Milky Way alone contains hundreds of billions more, one orbiting nearly every star in the sky. The light entering your eyes tonight has passed through a galaxy teeming, almost certainly, with worlds. When completed, the square-kilometer array will be the largest radio telescope ever built, a vast network of thousands of individual antenna dishes and receivers spread across the landscapes of South Africa and Australia, their combined collecting area totaling 1 square kilometer. Together they will form a single instrument of extraordinary sensitivity, capable of detecting radio signals from the earliest galaxies, mapping the magnetic fields of the cosmos, and listening for patterns in the deep hum of the universe that no single telescope could ever hear alone. It is science built from collaboration. Many nations, many hands, many small receivers turning together toward the same immense and unhurried sky. NASA's Artemis program carries a purpose that reaches beyond engineering and trajectory. It aims to return human beings to the surface of the moon, and among them, for the first time, a woman and a person of color will stand in the lunar dust and look back at the Earth. The program takes its name from Artemis, the twin sister of Apollo in Greek mythology, a quiet acknowledgement that the story of human spaceflight has always belonged to all of us. The moon has waited patiently for more than 50 years since the last footsteps faded from its surface. When the next ones arrive, they will carry the weight of a wider humanity. To support the Artemis missions and future journeys deeper into space, NASA and its international partners are building the Lunar Gateway, a small modular space station that will orbit the moon rather than the Earth. Unlike the International Space Station, the Gateway will not always have a crew aboard. It will serve as a waypoint, a place to rest and resupply between Earth and the lunar surface. Its orbit carries it on a wide, elliptical path that brings it close to the moon's south pole, where water ice lies frozen in permanently shadowed craters. The Gateway will be modest in size, but immense in purpose, a quiet harbor in lunar space, the first stepping stone on a much longer road. SpaceX's Starship is the largest and most powerful launch vehicle ever built, a fully reusable rocket and spacecraft system designed to carry more than 100 people at a time on journeys to the moon, to Mars, and eventually beyond. Both the upper spacecraft and the enormous booster stage are intended to return to Earth and land upright, to be refueled and flown again, the way an aircraft is turned around between flights. The vision behind Starship is one of radical abundance. If reaching space becomes as routine as crossing an ocean, then the solar system itself becomes a place humanity can gradually, carefully begin to inhabit. Let your breath slow now, even more than before. There is no need to hold on to any of these images or words. Let them drift away like the last light of evening leaving the sky. Feel the places where your body meets the surface beneath you, and let yourself sink a little deeper into that support. Your shoulders can soften. Your jaw can release. Every part of you that has been working today is allowed now to simply rest. You have traveled far tonight, through centuries of wonder, through the long arc of human longing for the stars, and now the journey quiets. Now there is only stillness and warmth, and the slow, unhurried tide of your own breathing carrying you gently toward sleep. NASA's planned Mars sample return mission aims to bring Martian rock samples back to Earth for careful analysis. The Perseverance rover has already been collecting small sealed tubes of Martian soil and stone, setting them gently on the surface like a trail of quiet gifts waiting to be retrieved. When those samples finally arrive in laboratories on Earth, Scientists will be able to study them with instruments too delicate and complex to carry across the solar system. A handful of red dust, gathered from a world 200 million kilometers away, may hold the most profound answers humanity has ever sought. Water ice confirmed at both lunar poles could one day be used as rocket propellant for future missions. Tucked inside permanently shadowed craters near the Moon's south pole, this ancient ice has rested undisturbed for billions of years, never touched by sunlight. With the right equipment, that ice can be split into hydrogen and oxygen, the very components of rocket fuel and breathable air. The Moon, long thought to be a barren and lifeless place, quietly holds within its frozen shadows one of the most valuable resources in the entire inner solar system. The concept of in situ resource utilization would allow astronauts to produce fuel and breathable oxygen directly on Mars, using the materials already present on the planet. The Martian atmosphere is thin but rich in carbon dioxide, and the soil holds water ice not far beneath the surface. By processing these local resources, future explorers could sustain themselves without waiting for resupply ships from Earth. It is a principle as old as exploration itself, living off the land, carried now to a world where the land is red and the sky is the color of a faded rose. A human mission to Mars would take approximately 7 months of travel each way, with astronauts spending that time in the quiet, weightless interior of a spacecraft far from any world. The journey would cover hundreds of millions of kilometers of open space, with no possibility of a quick return if something went wrong. Days would pass in a steady, unhurried rhythm of meals, exercise, sleep, and the slow turning of instruments. Outside the windows, the sun would gradually shrink to a brighter star, and Mars would grow from a faint point of rust, colored light, into something that finally looked like a destination. Astronauts on long deep space missions face radiation exposure far greater than anything experienced on Earth or even aboard the International Space Station. Beyond the protective embrace of Earth's magnetic field, the solar wind and cosmic rays pass through the body with little resistance. Over the course of a Mars mission, the accumulated exposure would be equivalent to thousands of chest X-rays, absorbed gradually across many months. Engineers are working on shielding materials and mission designs that minimize this risk, understanding that the human body, carried so far from home, must be carefully tended. Microgravity causes bone density loss of about 1 to 2% per month in astronauts living in space. Without the constant, gentle pressure of gravity pulling on the skeleton, the body gradually stops reinforcing its own structure, as though it has decided the bones no longer need to bear any weight. Astronauts on long missions exercise for hours each day, using specialized resistance equipment, working to slow this process and keep their bodies strong enough to return to a world with gravity. The human frame was shaped over millions of years to live on Earth, and it remembers that, even among the stars, closed, loop life support systems must recycle air and water with near-perfect efficiency for Mars missions, because there will be no resupply from Earth. Aboard the International Space Station, water recovered from breath, sweat, and other sources is purified and returned to the crew, a cycle that is both remarkable and quietly essential. On a Mars mission, that cycle must be even more reliable, losing almost nothing over months and years of operation. Every breath exhaled, every drop of moisture, becomes a resource to be gathered and returned. Life in deep space is sustained by an extraordinary, invisible conversation between the human body and its machines. The first permanent Mars base would likely be built underground, carved into the planet's ancient rock to shield its inhabitants from radiation. On the surface, Mars offers little protection. Its thin atmosphere and absent magnetic field leave the ground exposed to solar and cosmic radiation that would be harmful over long periods. But beneath the surface, even a few meters of soil and stone provide meaningful shelter. Future inhabitants might descend each evening into warm, lit corridors tunneled into the Martian rock, living their lives in a world that is both alien and, in its own way, quietly sheltering. Terraforming Mars is theorized to involve releasing greenhouse gases into the planet's thin atmosphere to warm it gradually over many centuries. If the planet could be warmed enough, the frozen carbon dioxide at its poles might sublimate, thickening the atmosphere and raising pressure across the surface. Over immense spans of time, perhaps hundreds of years, perhaps thousands, liquid water might once again flow across the Martian plains. It is a vision of extraordinary patience, a project not for any single generation, but for the long, slow unfolding of human ambition across centuries we cannot yet imagine. Europa, one of Jupiter's moons, harbors a subsurface ocean holding twice the volume of all Earth's oceans combined, kept liquid by the gravitational pull of mighty Jupiter flexing and warming the moon's interior. Above this vast dark sea lies a shell of ice kilometers thick, cracked and ridged by the tidal forces that churn the world beneath. Scientists believe this hidden ocean may have existed for billions of years, warmed from below, stirred by chemistry, and perhaps, just perhaps, home to something living. The thought of an entire ocean, larger than all of Earth's seas, drifting silently beneath the ice of a distant moon, is one of the most quietly astonishing things our species has ever discovered. Let yourself settle a little deeper now. There is nowhere to be, nothing to hold, nothing to carry. Let your shoulders release. Let your hands rest open and still. Breathe in slowly, and breathe out even more slowly, as though you are breathing out the last of the day. The universe is vast and unhurried, and tonight, so are you. Simply let yourself drift, carried gently by the quiet wonder of everything we have explored together. NASA's Europa Clipper spacecraft was launched in the year 2024, beginning a long, graceful journey toward Jupiter to study whether Europa's hidden ocean might be capable of supporting life. The spacecraft carries an array of instruments designed to measure the composition of Europa's ice shell, the depth of the ocean below, and the chemistry of the plumes that occasionally vent from its surface. It will arrive after traveling hundreds of millions of kilometers through the quiet dark of the outer solar system. Slowly, patiently, it will answer questions humanity has held for decades. Enceladus, one of Saturn's smaller moons, is one of the most astonishing worlds in our solar system. A bright, icy sphere that actively vents water vapor and organic molecules out into space from great fissures near its south pole. These plumes arc upward, like the breath of a living world, seeding Saturn's outer ring with fine particles of ice and chemistry. Scientists believe a liquid ocean lies beneath Enceladus's frozen surface, kept warm by tidal forces, rich with the building blocks that life requires. That a moon so small could hold such extraordinary secrets is a reminder of how generously the universe conceals its wonders. The Drake equation is a quiet, elegant attempt to reason through one of the deepest questions humanity has ever asked: how many civilizations in the Milky Way might currently be sending signals we could detect? It was written by astronomer Frank Drake in 1961, and it walks through a chain of factors. How many stars form each year? How many have planets? How many of those planets might support life? And how long a civilization might support life? And how long a civilization might survive, long enough to communicate? No one knows the values of all those factors with certainty, but the equation itself is a kind of poetry, a way of holding the question open, carefully and without fear. The Fermi paradox rests on a simple, open observation. Given the enormous age of the universe and the vast number of stars it contains, one might expect signs of other intelligent civilizations to be detectable by now, and yet, so far, silence. The physicist Enrico Fermi reportedly asked, simply and quietly, "Where is everybody?" Scientists have offered many thoughtful possibilities. Civilizations may be rare or brief or communicating in ways we have not yet learned to hear. The silence is not frightening. It is a wide-open space that our curiosity has only just begun to explore, like standing at the edge of an ocean and listening. The search for extraterrestrial intelligence, known as SETI, has been listening to the radio frequencies of the cosmos since 1960, when astronomer Frank Drake pointed a telescope at two nearby stars and simply listened. In the decades since, researchers have scanned millions of frequencies, sweeping across stars and galaxies in patient, methodical hope. No confirmed signal has yet arrived, but the listening continues, unhurried and persistent. There is something deeply human about it, the act of turning an ear toward the dark, not in urgency, but in the quiet faith that the universe may one day answer. Breakthrough Listen, established in 2015 with generous private funding, became the most thorough and systematic search for signals from other civilizations ever undertaken. It surveys the nearest million stars, the center of the Milky Way, and even nearby galaxies, listening across a broader range of frequencies and with greater sensitivity than any previous effort. The program processes enormous volumes of data, sifting through the hum of the cosmos for anything that might be deliberate, structured, and not of natural origin. It is one of the most ambitious acts of listening in human history, an ear pressed gently to the wall of the universe. A Dyson sphere is a theoretical structure imagined by physicist Freeman Dyson, a vast shell or network of collectors built around a star to gather nearly all of its radiated energy. A civilization advanced enough to construct one would have access to power on a scale almost impossible to comprehend, drawing on the full output of an entire sun. It remains, for now, an idea, a thought experiment about what intelligence might eventually build, given enough time and ingenuity. The light entering your eyes from distant stars tonight may, for all we know, be the filtered glow of something we have not yet learned to recognize. Generation ships are a vision of extraordinary patience. Vast spacecraft designed not to carry their original crew to a distant star, but to carry their descendants, born and raised across many generations in the quiet corridors of a vessel traveling through interstellar space. The journey might take hundreds of years, the destination unreachable within any single human lifetime. Those who departed would never arrive. Those who arrived would never have known Earth. It is a profound and tender idea that love for the future might move us to begin a journey we ourselves will never complete, trusting the generations that follow to carry it forward. Cryosleep, or suspended animation, remains a theoretical possibility for human voyages across the vast distances between stars, a way of slowing the body's processes so deeply that years or decades of travel might pass like a single night of rest. In nature, certain animals enter states of profound dormancy, their heartbeat slowing, their metabolism falling to near stillness, and then gently awakening when conditions change. Whether human biology could be guided into something similar remains an open and carefully studied question. There is something quietly beautiful about the idea that the deepest sleep imaginable might carry us, unhurried and dreaming, to worlds we have never seen. Warp drive remains theoretical, but physicists have proposed a mathematical framework known as the Alcubierre metric as a way of imagining how faster-than-light travel might one day be possible. The idea, put forward by physicist Miguel Alcubierre in 1994, does not move a spacecraft through space in the ordinary sense. Instead, it describes a way of bending space itself, contracting it ahead and expanding it behind, so that a vessel rides a kind of wave. The physics is genuine, rooted in the equations of general relativity, though the energy requirements remain far beyond anything we can currently imagine. It is less a blueprint than a beautiful whisper, a suggestion that the universe may hold doors we have not yet found the keys to open. Let your body settle a little more deeply now. Feel the weight of your arms, your legs, the quiet heaviness of rest moving through you. There is nothing to hold on to tonight, no thought that needs your attention, no question that needs an answer. Each breath you take is slower and a little more effortless than the last. The day has already moved on without you, and all that remains is this soft, unhurried stillness. You are safe, you are warm, and sleep is already finding its way to you, gently and without effort. Light sails propelled by powerful laser beams represent one of the most elegant visions in all of spaceflight. Thin, gossamer sheets of reflective material pushed forward by the gentle but relentless pressure of focused light. Unlike chemical rockets, which carry their fuel and burn it in a roar, a laser sail carries nothing at all, drawing its momentum purely from photons streaming across the void. In theory, a sail small and light enough could be accelerated to a meaningful fraction of the speed of light, reaching the nearest stars within decades rather than millennia. It is a quietly extraordinary idea that something as weightless and ancient as light might one day carry our first emissaries to another sun. Breakthrough Starshot, announced in 2016, envisions sending tiny probes no heavier than a few grams, each one a wafer of circuitry smaller than a postage stamp, accelerated by a powerful ground-based laser array to 20% the speed of light. At that speed, the journey to Alpha Centauri, our nearest stellar neighbor at just over 4 light-years away, would take roughly 20 years. The probes would fly through that distant system in a matter of hours, capturing images and measurements and sending them home across the void. It is an audacious, patient dream, one that asks us to plant a seed today that our grandchildren might see bloom. Proxima Centauri b is an Earth-sized world, orbiting within the habitable zone of Proxima Centauri, the closest individual star to our own Sun, lying just over 4 light-years away. Discovered in 2016, it completes one orbit around its small, dim red star every 11 days, held close in a gravitational embrace far tighter than Earth's orbit around the Sun. Whether it holds an atmosphere, liquid water, or any condition hospitable to life remains beautifully unknown. But the knowledge that a world of roughly our own size rests at the very first step of any future journey outward fills that distance with a quiet and enduring sense of possibility. The Milky Way, our home galaxy, contains an estimated 100 to 400 billion stars, spread across a luminous spiral roughly 100,000 light-years from edge to edge. Our own Sun rests about halfway out along one of its graceful arms, orbiting the galactic center on a journey that takes roughly 225 million years to complete. If you could somehow see the whole of it from above, it would appear as a softly glowing pinwheel, its arms wound in slow and ancient curves, each one holding billions of suns and the worlds that circle them. We live inside one of the most intricate and beautiful structures the universe has ever assembled. The observable universe, the portion of all that exists that light has had time to reach us from, contains an estimated 2 trillion galaxies, each one a vast island of stars, gas, dust, and time. 2 trillion is a number so large it dissolves into pure abstraction, like trying to count individual grains of sand on every shore of every ocean. Each of those galaxies holds billions of stars, and around those stars, worlds beyond counting. The sheer scale of it all does not diminish us. It deepens the wonder of the fact that here, on one small and fortunate world, something arose that could look outward and begin to understand. The cosmic microwave background radiation is the oldest light we can observe, a faint, uniform glow that fills the entire sky in every direction, the afterglow of the universe's earliest moments. It dates to approximately 380,000 years after the Big Bang, the moment when the young universe had cooled just enough for atoms to form and light to travel freely for the first time. That ancient warmth still washes over us today, shifted by billions of years of cosmic expansion into microwave frequencies far below what our eyes can see. When you lie still tonight, that primordial light is passing through you, the universe's oldest memory, still moving, still present, still here. And so we arrive at the edge of everything we have imagined together tonight. From stone circles aligned with the rising sun, to footprints pressed into lunar dust, to whisper, thin sails chasing the light of distant stars, humanity's journey into space is the story of a species that looked up and could not stop wondering. You are part of that story. Every question ever asked about the sky above, every dream of other worlds, every quiet moment of looking up and feeling the vastness, all of it lives in you too. Tonight, let the stars keep their ancient watch while you rest. The universe is patient and immeasurably wide, and your place within it is safe and sure. Sleep well, dear traveler. You have come so very far,